Welcome back to Survey of Engineering. We are now in our chemical engineering unit, and during this lecture we will be talking about the project that we will be doing during this unit. Here are your portfolio questions that you should be answering during this lecture or afterward. First, list 3 reasons why alternative energy is appealing. Second, explain why algae is a good choice as a feedstock for biodiesel production. And third, list the overall process steps to biodiesel production from algae. So let's talk a little bit about energy and chemical engineering and how chemical engineers relate to the field of energy production. Traditionally, chemical engineers work in areas of fossil fuels and obtaining energy from fossil fuels. The first chemical engineers began or were developed as oil was discovered, crude oil was discovered, and chemical engineers, the first problems they worked on was how to take that crude oil and make it into something useful, gasoline, diesel, jet fuel, and other types of products. So chemical engineers work in industries where coal or petroleum products are processed and natural gas is extracted and turned into usable sources of energy. Also, chemical engineers are employed in the field of nuclear energy and nuclear power plants also, and this is where we will focus this unit. Chemical engineers are employed in producing energy from renewable fuels that come from biomass feedstocks, things that are like algae, like we'll be talking about, solar power, wind power, geothermal, among others. So why do we need alternative energy? What is the purpose to wanting to explore this field? Well, first, the reason that we want alternative energy is we want to reduce our dependence on fossil fuels. Fossil fuels meaning things like crude oil and coal and things that we get out of the ground. So let's talk about why we want to reduce our dependence on these things. First of all, combustion of fossil fuels or burning of fossil fuels releases pollutants into the air, and that's not healthy, and we want to avoid that and avoid our damage on the environment. Also, the domestic supplies, meaning the fossil fuels that are available here in the U.S., generally have a higher cost associated with getting them out of the ground and often face environmental hurdles to getting them out of the ground and developing them, meaning there are regulations and things in place that companies have to face or have to follow in order to develop those fossil fuels. Also, crude oil from foreign sources is affected by politics in the world. If politics is unstable, then that translates into supply not being stable. We may have more supply from foreign sources or less supply depending on what is going on politically in the world. And that translates into a wide swing in prices for crude oil. So what are some zero emission options? By zero emission, I mean things that we're not burning to emit products or waste products. So these things include hydropower, geothermal power, wind power, solar, and nuclear power. Now, are there some carbon neutral options? Carbon neutral meaning things that consume carbon and emit carbon when burned, but when you add those together, the net change in carbon in the atmosphere is zero. So, yes, there are carbon neutral options, and this is the combination of energy and fuels and biochemical engineering to develop biofuels. Some typical distribution of energy sources where we in the world get our energy is shown here. Most of the energy that's used in the world comes from oil, coal, and gas, and a smaller amount comes from either biofuels or zero-emission fuels. So these things include nuclear, biomass, hydro energy, solar energy, wind energy. And you can see down at the bottom, biofuels is a very small percentage of the world's supplying the world's need for energy. This data is a little bit old, but it hasn't changed a whole lot between 2005 and 2014. As of 2014, the biofuels supply was about 0.5% of the supplying the world's energy needs. So there's a great opportunity for improvement if we can find an economically viable or a cheaper alternative of a biofuel to supply energy sources, and a great need for it in the world. So what's a biofuel? Basically, a biofuel is any fuel that is derived from a biological process. This could be things like corn and soybeans, which are often used to create things like ethanol or extract oils, vegetable oils from that we can turn into biodiesel. It could be gas emissions from decomposition or livestock, or it could be pulp waste from grasses or woods, turning those into biofuels. So anything that comes from a biological that we can turn into a fuel that we can use and get energy from. So there are lots of sources that we could consider for biofuel production. Some are shown here. Most of these are crops, palm oil, coconut oil, various different oils. You can see corn, soybean, and other sources. And we estimate that algae could produce up to 10,000 gallons of oil per acre of production site. So if I plant an acre of corn, I can only expect to have maybe 18 gallons of oil per that acre of corn that I planted. But if I dedicate an acre to algae production, I can expect a possibility of 10,000 gallons of oil coming from that acre. So algae is very attractive in the sense that we get a nice large yield for the amount of space and energy that we would supply in order to produce algae. And the reason for that is that the energy that goes into growing algae is mostly going into just growing the cells. There's not a lot of structure of the plant that has to be grown. For in the case of corn, if you think about how a corn plant grows, the kernel where the oil sits is a small part of the whole corn plant. Most of that corn plant's energy is taken up by growing the stalk and the leaves and all of that. So algae is a great option because more of that energy used to growing it is going to making the oil, and the oil makes up a greater part of what we get from the algae.